So today we're live with another video. This time it's going to be on control flow concepts and specifically on conditions and loops, and then with returns and jumps. So I always remember you to subscribe to the channel and start the notification bell so that you can get notifications when I live stream again. I hope that you are learning new stuff from these videos and that we go deeply into Kotlin. So let's start with the conditions and loops. As always, I remind you that I have a website which is also mentioned in the description of the website, and here we will have a recap. I am still a little bit late. I'm sorry with updating this, but we will have a recap if you want of this Kotlin course. I must update it when I have time, and I hope that's also a useful resource for you. So let's go on. We will talk about if expressions. If is an expression and it returns a value. Therefore, there is no ternary operator because ordinary if works fine in this role. So basically, this means that if will return a value like they're saying here, like you can see here in this example. And you can also have the else, of course. So if this condition is met, so if A is less than B or A is greater than B, then do something else. If this condition does not apply, then you can do something else. And this can be both an expression, so you can also assign max variable like this. And then what you might do is also have an else if statement inside. And if the first condition is met, then it will return max limit. Otherwise, if A is greater than B, it will return A. And else, otherwise, you can return B. So we can start with this very simple example. And let's go here. I have created a new function and new file, and I basically run it from here. So let's play with the if. Let's play with if. So as they are doing here, we will just create a variable which we will call max, and max will be, yeah, here it's a little bit stupid. Maybe we can do take max value between A and B, and we give two numbers, and we create a function which says A and B, and then what we do is we return, we say if A is greater than B, then return A. All right, and else we return B. So this will take the maximum value between A and B, and we can print it, and we can say max value is between Yeah, we could say also A and B as variable as values. We can declare them as values, and the max value between A and B is this, right? So we're using the if, then we have to, of course, to change the return type to integer, and now we're good. It's always 3, okay, because we're using it only once. There's no issue in that. Read or run. Yeah, so it's working. Then, so we have made an example with the is, with this, with the if else. Let's do it also in an expression, which basically what we could do is we could say PoliMax is equal to this, and then we remove the return, and then we say return max, right? So we're assigning it to a value before returning it, right? And this will also work as before. We could put a limit. So if max, let's take max value and let's add with limit. And the limit is going to be the last variable that we have in our parameters, and the limit is going to be a new value, and we want a limit of 10. So let's say that we have b as 44, but we limit to 10. What we want to do is we want to have 10 if the greatest value is 44 instead of 44. So basically we can say, yeah, here it's going to be a little bit of a different output, but what I want to show in this case is if a is greater than limit or b is greater than limit, then we return limit. Else, if a is greater than b, we return a, else we return b. So that's what I want to do in my example. I want to put a limit, and if a or b are greater than limit, we return limit. Otherwise, if a is greater than b, we return a, and otherwise we return b. So that's my example. Let's see. Yeah, we have 10 because of course limit overall limit to 10, which is limit. All right, so let's go next. Branches of an if expression can be blocks. So of course inside the expression, if expression, you can do other stuff. You can, for example, say the max limit is reached, and so you can see that this will be printed as output if you reach the max limit. If you're using if as an expression for returning its value or assigning it to a variable, the else branch is mandatory. So yes, of course, you cannot do this. Otherwise, it will say that you must have the else branch when you are assigning to a value. This is not true in case you just want to print something like this. A is greater than b, In this case, you don't need to 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 place an else branch. No need for else branch. Right? This is the example that I have here. We could also say, yeah, the max limit is reached. No need for else branch. All right. Next, when expressions and statements. So the when is a conditional expression that runs code based on multiple possible values or conditions. Yeah, so it's similar to the switch statement in Java and C or similar languages. Let's make an example with this one. So let's do. Let me think of an example. This one is a little bit stupid. What we may do. Yes, we may replicate the same example that we have here with the when as a starting step. So with when, let's create the function and let's put this an int. And now, so we do when, and since we have a particular condition here, which is a is greater than limit or b is greater than limit, we want to do it in this way. We don't have to place necessarily a variable in the when condition, but in this case we need the else branch as well also here, and the else is going to be b, but we still have the a greater than b condition, and then to return a in this case. And from my perspective, this way with the when is more readable, but here it depends on your personal preference, of course. I mean, I like very much this syntax. So now we should have the same result as before, and indeed we do have it. So one more thing we could do is we could directly with the when, we could directly say when we have this variable do this, otherwise do something else. So maybe I want to show this example in another way. So let's create a new class, and let's call this just a second, I'm searching for the word. So the stoplight or traffic light, better, traffic light. In this case, I want to have red, yellow, and green. So these are the three colors of the traffic lights, of course, and I want to use the when with the traffic light. So let's say run condition on traffic light color. So in this case, I want to pass the red color, and I will import it. I'm sorry, I will explicitly say that I want a traffic light class, and then I will create a function for this. So this has to be traffic light, more generic parameter, and then I want to have a when, and I want to print some stuff based on the traffic light color. So let's say traffic light. Yeah, we could say color, traffic light color when, and in this case, so as you saw here, I am passing now the traffic light to the when condition, and the compiler will say, hey, you must either add an else branch, and it will be fine, but of course that version will be unused, or you have to add the branches with or without the import. There it depends on your personal preference. I prefer this type of syntax. And in this case now I want to print line, some phrase. And in case of red, I want to say you cannot proceed. In case of yellow, you can think, you might think that you can proceed soon. And in case of green, go as fast as you can. So now with the color red, you cannot proceed, of course. And with the other colors, you will get the different output for the print line. So in the when, you can either do everything in one line like this, or you may create an expression with brackets and do other stuff while you're here. So like we could say val internal status, like stopped. An internal status could be stopped, and this could be set to false by default, and stopped would be true if the value is red. Of course, we have to make it a variable, and this would be the same if the value is yellow, because you have to be stopped in this case. And in case of green, it could be that it's false. So you can have also the brackets here. All right, so when matches its arguments against all branches sequentially until some branch condition is satisfied. So it will go from first to second and so on. You can use when in a few different ways. Firstly, you can use when either as an expression or a statement. As an expression, when returns a value for later use in your code. As a statement, when completes an action without returning anything of further use. So in this case, we are not returning anything, but we could. So why not do that? So we can say stopped equals to something. Instead of passing stopped here, we could pass stopped as the last element of the expression, and this would mean that I am returning this to inside the when. So stopped will be true, as it was as we were previously mentioning. So we can do this also for all other expressions, and we will get the result in the same way. So we can also say that we want to return stopped in our function. And of course, this is redundant because now we actually don't need that. We could say this is a value directly and assign it inside the yeah, and assign it this way because the when is now returning some value. So in this case, we're using when as an expression and not a statement anymore. Secondly, you can use when with or without subjects. Okay, so we already saw this. We have used when with a subject here, and we have used the when without a subject in the first example that we made. Whether you use a subject with when or not, your expression or statement behave the same. So we recommend using when with the subject when possible, as it makes code easier to read and maintain by clearly showing what you're checking. As I said before, I agree with this, but I also like to use the when in case I don't have the subject. Depending on how you use when, there are different requirements for whether you need to cover all possible cases in your branches. So depending on when you use when, there are different requirements for whether you need to cover all possible cases in your branches. So if you use when as a statement, you don't have to cover all possible cases. In this example, some cases aren't covered, so nothing happens. Okay, so in the case of basic type integer, and not all cases are covered, and nothing will happen in case the condition is not met. In a when statement, the values of individual branches are ignored. Just like with if, each branch can be a block, and its values and its value is the value of the last expression in the block. So the values of individual branches are ignored, just like with if. Each branch can be a block, and its value is the value of the last expression in the block. So that's what we've done here. The value is true, and it's the last expression inside the block. If you, oh god, if you use when as a statement, you don't have to cover. Okay, we read this. If you use when as an expression, you have to cover all cases. In other words, it must be exhaustive. The value of the first matching branch becomes the value of the overall expression. If you don't cover all cases, the compiler throws an error. If your when expression has a subject, okay, so let's do what we have just said first. Let's create this value unknown inside the traffic light. If I run this, it will throw an exception, the compiler, because we must, when expression must be exhaustive, add the unknown branch or an else branch to the when. So basically, I need to have a when, and I need to specify also value, since I'm using this as an expression and not as we said before, as a statement. So in case I add more, like more traffic light options, like unknown or broken, then it will still go inside the else. I suggest you, since it's possible to add many of many other cases inside a enum class to avoid using the else in this case. Only if, of course, you don't have a lot of branches, but in this case, it's preferred to specify the value for each of the enum constants, so that when you add a new one, like no connection, you get the warning here, and you can say add remaining branches, and it will do that on its own. So let's go on. If your when expression has a subject, you can use an else branch to make sure that all possible cases are covered, but it isn't mandatory. So yeah, that's what we have done there. Yeah. For example, if your subject is a Boolean enum class, CL class, or one of their nullable counterparts, you can cover all cases without an else branch. Yeah, so in case of the enum class, you can do what we just said. So you can cover all the cases. We can do that also with CL and Boolean. So let's try this. CL class. Let's say bit, and let's say object 1, and let's say this is a bit. Yeah, constructor indicator object 0, and then say bit. Right. Yeah, we can convert to data object as suggested here, and now we can say same as we're doing here, run condition on bit, and then we can say bit dot, yeah, we could say directly 1, and then yeah, import. Okay, create function. Here we might specify just bit, and here we might specify bit as well, and then we can say when bit, and as you can see here, it will say add all the remaining branches as we are doing with a when, and here we can say this is 1, and in the other case this is a 0, of course, 0. And the same thing can be done with the booleans, the boolean, and here we say when b, and let's remove all of that, and yeah, add remaining branches. In this case, same as true as with 1 and 0, we can say true and false, and yeah, basically the true is 1 and the false is a 0 in programming languages. So we will have the same outputs here. What we could do to do something funny, thinking of this, might have private b integer, sorry, private all, and then we could say this has to be the value, and here we say 0, and here we say 1, And we could do, instead of passing that, or actually, yeah, instead of zeros and ones, we might have another condition here, and we say, oh, this is I, sorry, and this is B, and then we say if I equals to 0, then we say false, else true. So what I'm trying to do is I'm trying to apply what we have learned in the previous courses. So basically we have a parameter inside the class that has to be specified. Then we have two objects inside this CL class, and each yeah, basically we can remove the redundant if, but the idea is that inside this if we have 0, it's going to be false, otherwise it's going to be true. And now here, instead of true, what I could do is I could put 1 dot b. Yeah, of course this has to be public or internal, yet better. And now we are going to be able to access this b value, and this Boolean condition will be based on that, right? So I think this example was nice. I hope it was for you as well. And yeah. So let's go on. We have read this already. What you can do as well is that you can specify with a comma multiple conditions. So for example, let's get back to the traffic light example. Since all of these will have the same result, we could do broken and with the comma, and traffic light with no connection, and we could say that all of these have false values. You can use arbitrary expressions, not only constants as branch conditions. Okay, that's of course what we have done here as well. And you can also check whether a value is or isn't contained in a range or collection via the in or not in keyword. So let's make an example with this. Maybe we could also do this, but of course in this case the not the compiler, but yeah, the compiler might complain actually. So I wouldn't suggest it. I would suggest it only if you have ranges that are have different sizes, like if 1 to 10, 10 to 11, and so on, 10 to 20, and so on. Remember always that when you do this, you will start from the first condition and then go on with the other condition. So it's sequential. Don't expect that if the first condition isn't met, yeah, don't expect that if the first condition is met, you might have the result of the third condition. Also, if that one is met, maybe it's better to do the example with the numbers here. So let's say run a condition if inside range is. So let's say we have number 5, and then let's say when I. So let's make a simple example in 1 to 10, and let's say print line, and then let's say inside 1 to 10 range. Otherwise, we want to say inside 115 range, and you will see that although it's inside 115 range, we only get this as output. And yeah, else we do nothing. So let's run this, and when we place a number of value 5, then we get only the first expression that we have declared. Otherwise, if we place a number between 10 and 15, so like 14, we get the second expression because it sequentially goes here. And otherwise, if we go above it, like with 22, we don't get any output because we're not printing anything. And of course, you can also negate this expression, and in this case, you would get the output not inside this range. All right. So it would be we could also do something like this. Additionally, you can check that the value is or isn't a particular type via the is or is not, of course. So we can check the types. We have already done that. And due to smart class, you can access the member functions and properties of the type without additional checks. So we have done this already. So let's check in a previous live stream. So we'll go very quickly on it. Run condition based on type, and then we pass some type here. We say that this is X, and it is a type of any, and we can say if X is a string, then we output its X is a string. Otherwise, if it's an integer, then we say X is an integer, and we multiply it by 10, for example. And this is possible because we have smartcast inside the expression after the is check. So in this case, we can say starts with, I don't know, C, capital C. So if we say ciao, then it's going to be, it's going to print yes, true, sorry. Otherwise, otherwise not. And if we pass a number, it's going to be multiplied by 10. And of course, if I want to access starts with, I cannot do it here because this is going to be an integer. So yeah, here it says value parameter x, but it's actually casted to the type. So yes, as you see here, the 3 is going to be multiplied by 10 and it's going to be 30, and the string is going to be printed with starts with C check. You can use a when as a replacement of the if as if chain. Of course, we have done that. If there's no subject, the branch condition are simply Boolean expressions, and the first branch with true condition runs. So we've already seen that. You can capture the subject in a variable by using the following syntax. Okay. So yeah, this is quite interesting because you might need to do that in your code. You can capture the value of the subject inside a variable that can later be used also inside your code. So I cannot think actually now of an example. Let me think. Maybe we can adapt something here. Yeah, we could do something like multiply by 22. Yeah, sorry, multiply by 10. Let's say. So we're passing 2 now, and here we're getting 20. And what I want to do is I want to say this is x, and then I want to print the value of x inside the expression, and I want to show it here so that I know that I know the result of this expression, which is going to be 2 times 10. And in fact, what I'm seeing here, is that x is going to be 20 because we're multiplying it by 10 and we're capturing the result inside the subject. Okay, guard conditions are experimental and may change. Guard conditions allow you to include more than one condition to the branches of when, making complex control flow more explicit and concise. You can use guard conditions in when expressions or statements with a subject. To include a guard condition, place it after the primary condition, separated by the if. Place it after the primary condition and separated by the if. So branch with only primary condition calls feed dog when animal is dog. Okay. And branch with both primary and guard conditions called feed cat when animal is cat and it is not mouse hunter. So in this case, we are also having the if of inside the if condition inside this when. And this can be useful when you have a subject and want to add a particular if condition. So let's try it in our examples. I think that it's better to do it with the traffic lights. Let's go here. So instead of having the stopped as inside the when, what we could do is we could say traffic light all stopped equals to false. And yeah, we have to specify the type. And in case of green, we will say it's true. So the stopped is going to be true only in case of green light. Sorry, it's the opposite. So stop is true in all cases except of green. And now what we are going to do, yeah, this doesn't make lots of sense. Pa, pa, pa. Maybe, yeah. If you want to check if that condition is okay, then you could actually do it, because you can do traffic light color dot stopped equals to true. Okay, so it says when guards is not supported in K1 mode. So I think we need to check why. K1 mode, enable K1 mode, not K1, but and we will not run this. So I will just point it out here if you want to look it on your own, that you need to check how to disable K1 mode or how to use another compiler mode, basically. So we'll skip this part. You can combine multiple guard conditions inside the if. Yeah, it says here that to enable guard conditions, you can run the following command or add this to the build Gradle. So build Gradle KTS, build Gradle KTS, and go here and add this. Now let's try and run it. Maybe it should work. So yeah, we don't need a comma, sorry. So let's see if it runs with the green light. Compilation error. All right, I have to put the is. Okay, so it's not allowed over new entries. When guard is not supporting anyone, yeah, it keeps complaining of that. It says there's a syntax error anyway. So he's doing it with the data classes. Maybe let's try this with the data classes and sorry, with the shield interface. If it doesn't work, we skip this part. So in our example over here, 1 bit, bit 1. So we can say if bit 1 is sorry, if bit dot we have to say is yeah, this is checks the type if it's 1 or 0, if the type is 1 or 0, and then this should let's get here again, the I should be the let's see. Still says it's not supported. Yeah, I don't know why this feature isn't supported. Say it still isn't supported. That's quite strange. Maybe we have to add this line on top, but I don't think so. Yeah, still doesn't work. I'm not sure why. We will have to double check. But condition example is this one is bit 1. Let's keep it like this, and let's go on with the remaining stuff. For loops. Okay, so we're still here, guys. I thought it would be quick here, but it's not. So for loops iterates through anything that provides an iterator. This is equivalent to for each loop in languages like C#. The syntax for is the following: for item in a collection. So let's do this. Let's comment play with conditions, and let's play with loops, and let's go to this function. Now we will have like cycle in collection, and then we will create a function, and we will say for I in a range of 1 to 10, and then we just print the item I. So these are all the numbers from 1 to 10, and we're using the collection. Next, the body of for can be a block. Of course, yeah, we have done this already, as you've seen here. As mentioned before, for iterates through anything. This means that it has a member or extension function iterator that returns iterator which has a member or an extension function next, and which has a member or an extension function has next. So all of these three functions need to be marked as operator. To iterate over a range of numbers, use a range expression. All right, so let's see if there is something more here. Range. Okay, we can skip this example since we have done it in a previous live stream. Then we have a for loop. A for loop over a range or an expression is compiled to an index-based loop that does not create an iterator object. So in this case, with the ranges, we do not create an iterator object, but it's compiled over an index-based loop. A for loop over a range or an array is compiled to an index-based loop. So we have basically an array. If you want to iterate through an array or a list, you can do this in that way. So for example, cycle in a list, let's do for L in list of 1 to, well, yeah, let's say A, C, B, C, and then in line L, and then this will cycle through the elements of the list. Alternative, you can use the with index to get the index of the array. And indices, if we do indices, what we will get is 0, 1, 2, 3, 4, and this means that we're cycling through the indexes of the list. And we can also say with index, and they're saying there, and we can say index and then value, and this will allow us to access both the index and the value of the mentioned array. Yeah, of the mentioned list, sorry. While loops while and do while loops process their body continuously while their condition is satisfied. The difference between them is the condition checking time. While checks the condition, and if satisfied, processes the body and then returns to the condition check. Do while processes the body and then the condition checks. If it's satisfied, the loop repeats, so the body do while runs at least once, regardless of the condition. So let's show this here. While loop, example, create function. While x is greater than 0, x minus minus equals 1. So, well, what I want to do is I want to start from 10 and then decrease the value up to 0. When this is done, then it will, after cycle, we have x. So cycle x is equal to this. Then we run it. After cycle x is equal to 0. But if we do x is equal to 10 again, and do this, so x minus 1 equals 0, while x is greater than 0, let's see which result we have. We still have a result of 0, but what happens if I give here a value of let's say something less than 0, so minus 1. This condition will be always false, And so anyway, yeah, this doesn't matter to me. What I want to show is that I'm running the -1 anyway, so instead of -1, I have -2 here. And if I do the same here, so if I place -1 here, this condition is going to be false, but the x is going to be -1 and not -2. So that's what I wanted to show. And this means that do while runs the expression of the body once before checking the condition. Kotlin supports break and continue operators in loops. So C returns and jumps. This is quite short, so we'll do it. Kotlin has three structural jump expressions are returned. By default returns the nearest enclosing function or anonymous function, the break, which terminates the nearest enclosing loop, and the continue, which proceeds to the next step of the nearest enclosing loop. All of these expressions can be used as a part of a larger expression. So the type of these expressions is nothing type. So let's do something. I want to try and understand the example here. I might not be able to do it, but let's try it. Hello. Then we do, yeah, we say this is a variable. Then we change the value to null. No, not null, actually, return. So yeah, this is nullable. Or if it's nullable, green line S. See what's happening. Interesting. It doesn't know which print line to use. That's strange. I don't know if I'm able to understand this example at this moment. So let's take a look at the break and return. Any expression in Kotlin may be marked with a label. Labels have the form of an identifier followed by the @ sign, such as ABC sign, @ sign, foobar, and so on. To label an expression, just add a label in front of it. Now you can qualify a break or continue with a label. So what we could do here in the for, we could say add loop at, sorry. And then we could say here if I is less than 5, then break loop. And this will break the loop in case we reach 5 already. Right, sorry guys, I have to move this and let's spawn again. So if we get to less than 5, we already break this loop. where is this cycling collection? Oh, if it's greater than 5, sorry. So we get them up to 5. So the break basically breaks the cycle, and a continue proceeds to the next iteration of that loop. So for example, let's say that we reach number 3 and we want to skip the number 3 printing, we can do that. And with the continue, as you can see, I'm not printing 3 anymore, and we are continuing inside for cycle. And return. In Kotlin, functions can be nested using literal, local functions, and object expressions. A qualified return allows you to return from an out of function. The most important use case is returning from a lambda expression. To return from a lambda, label it and qualify the return. So let's make this very simple example that we have here. Cycling list. Right, we are cycling inside list, but we can do it in a little different way. So for each of these, right? If you don't allow me, yeah, because I have to list here for each these. Then we have index and value. Not possible. All right. We should if it dot value is equal to d, then what we can do is we return lit, and but to do that we must mark the lit the expression here as lit. And now so basically when let's say C, when we have the C we don't print it, and in all other cases we print both the value as we were doing before and the index. So index and value is value, and if we run this we should get only the 0 and 2 index is because we're returning upon this condition. All right. It is more convenient often to use the implicit labels because such a labels has the name of as the function to which the lambda is passed. So you could also, instead of doing this, you could also do for each, and then here you could say either return or return at for each, because that's also a possibility. You might also remove the implicit, the explicit at for each label and just leave return. It's going to work anyway. So yeah, it says in fact that a return statement is an anonymous function and will return from the anonymous function itself. Note that the use of local returns in the previous three example is similar to the use of continue in regular loops. There is no direct equivalent for break, but it can be simulated by adding another nesting lambda and non-locally returning from it. So this could be an example of a break. Basically, you could what you could do is you could say, if I reach the value C, example of break. And here we have an example of continue. And here we have example of continue. And in this case, what we can do is we can do run, and then we can run loop at. And at this point, since I want to break everything, if I reach the value C, I can say return at loop. So this condition will break. Duplicated code fragment. Okay, so let's say break loop. Let's see now. All right, it's a code fragment. Who cares? And in this case, as you see now, we're breaking the loop when we reach the C. And this is similar to break. All right. I think that when returning a value, the parser gives preference to the qualified return. This means return 1 at label at A rather than return a lambda expression. So I think you can return also a value here. Oops. Let's try. Yeah, as you can see here, I have is broken, and I can say the break condition is met, and I can say is broken, true or false. This might be useful in some cases. The break condition is met, yes. Otherwise, we could try to place other letters here and see if it returns false in this case. And yes, it does. So I think we have done everything we could in these conditions and loops and return and jumps, and I hope that this video is helpful for you guys if you want to get a deep learning of Kotlin. So please subscribe and activate the notification bells in order to get notified when I live stream again. Thank you guys, and have a nice day.